to the current flowing through it is directly proportional to the current flowing through it. So basically it's the Ohm's law. Now what is happening here is that there is another term which is known as conductance. Conductance. What is it? So if you see that V is directly proportional to I, and if I remove this proportionality sign, I'll end up getting a constant which is known as R. V equals to IR. And R is what? R is my resistance. Resistance. R is what? R is my resistance. So basically resistance is nothing but it is the opposition. It is the opposition in the flow of the ions, I can say that, or the current. Understood? It is nothing but it is an opposition.
Yeah.
Fine. So, or I can say that it is the obstruction in the flow of the current. Obstruction. Obstruction in the flow of current. Fine. Understood? Now, let's move on to the conductance. So what is it? It is basically the reciprocal of the resistance. So conductance is denoted by G and it is reciprocal of the resistance. So it is what? It is the ease offered in the flow of is offered in the flow of I can say that in the flow of the ions or the current is my conductance. Understood?
Yeah.
Huh? Now the next thing is my there is the thing which is associated with the resistance, which is your resistivity. Basically the formula for R would be rho L upon A. R equals to rho L upon A. Here rho is my what? Rho is my resistivity or the specific resistance. Specific resistance. Or I can say that it is resistivity. Resistivity. Understood? It is resistivity, or I can say that the specific resistance. What does it mean? It means that it is the resistance. It is the resistance of one unit length and 1 unit area of cross section. So it is what? It is the resistance of 1 unit length and 1 unit area of cross section. It is what? It is the resistivity. So, and
Resistivity.
it is not, and also it is not dependent on, it is not dependent. It is not dependent. It is not dependent on, length and your area. Why? Because the length and the area is already specified. It is the resistance which is offered by 1 unit length and 1 unit area of the cross section of the conductor. Understood?
Yeah.
So now,
Mm,
similarly, if the resistivity is there, then there is another term which is associated with the conductance, which is your conductivity. Again, it is the reciprocal. Conductivity is represented by K and it is reciprocal of rho. It is reciprocal of rho.
mm,
Understood?
yeah.
Okay. So we have discussed this. Yeah, correct. Resistivity, resistance. Now there is a question. Okay. Okay. Just 1 second. Okay. Conductivity is already defined. What is conductivity? And resistance is defined. Now there is another term which is your conductance. Conductance of a electrolytic conductor. So it is my. So basically, what it is your The conductance of the electrolytic conductor. Electrolytic, the conductance of electrolytic conductor is my what? Is my hello?
Wo- Yeah, could you help me?
So
Sorry.
basically, okay, I'll tell you. So the
This one. Yeah.
electricity conducted by all the ions present by dissolving a certain amount of electrolyte in a specific volume of the solvent is my conductance that I have explained you. Okay, I have explained this conductance here at this point, and now again I'm explaining you this thing.
Yeah.
Now there
Same
is
thing. Okay.
another term which is known as your there is another term which is known as your G star. What is G star? It is your cell constant. Cell constant. Cell constant. So what is this cell constant? So cell constant is your G star. It is represented by G star. And how this cell constant is defined? So basically, let us take an example of a beaker. Okay.
Okay.
So what is happening here is that I am having electrode like this. This is the electrode and this is the electrode. And the formula of my G star would be my L upon A. What is it? L upon A. So it is the ratio of the length to the area. It is the ratio of the length to the area. And length is of what? The length is in between. The length is basically is in between the distance which is there in the electrodes. Like this is the one electrode, this is the another electrode, and the difference between these two electrode would be my length. So length upon my area, and area is the cross-sectional area of this electrode. Okay. So
Okay.
basically, this is the G star. It is known as your cell constant. So if you see the formula of the resistance. So the formula of the resistance would be the formula of the resistance would be R equals to rho L by A. So if you see that, can I write this R? Can I write this rho as 1 upon K? Is it 1 upon R? Why? Because it is the resistivity and it is the conductivity. So resistivity is reciprocal is conductivity, which is kappa.
Yeah. Okay.
Okay, basically, see, this is the conductivity, and I am saying
Yes.
that this is pronounced as kappa. Okay, K, kappa, anything. It is the reciprocal of the rho. So if you see that, just one thing. So if you see that 1 upon K is equals to L upon A, and L upon A is what? G star. Understood? So G star is equals to RK.
Okay.
So this is the one of the most important formula that you have to remember. G star equals to RK. Or if you want to remember, so a mnemonic for remembering this formula that would be G star. Global star equals to Ranveer Kapoor. So there is an actor which is there in the India whose name is Ranveer Kapoor. If you know that, so global star equals to Ranveer Kapoor. So that's how you can remember. If you already know this thing, so it's fine. So this is G star equals to RK. Okay, fine. Now I'm going to give you the question. Before that, there is two things that is there. Just 1 minute. So if one would be your molar conductivity. So just one thing. So what is molar conductivity? Can you tell me? So basically, if you just go to the if you just analyze the name molar conductivity, you can easily tell me the definition of it. Why? Because molar conductivity is basically dealing with the molar wala thing. Why? The electricity conducted by all the ions produced by dissolving 1 mole of electrolyte. Understood? So basically, what is happening here is that there is a beaker like this. Just one minute. So there is a beaker like this. Okay. Now in this beaker, I'm just dissolving a solution, and this is the solution. This is the solution.
Yeah.
Okay, that I am dissolving. Now, after dissolving this solution, if my electrolyte is after dissolving the solution, the number of electrolyte produced on dissolving 1 mole of electrolyte. Okay, and they conduct the electricity. So the electricity that is conducted by all the ions that is produced on dissolving 1 mole of electrolyte is known as molar conductivity. Understood?
Yeah. Understood.
So 1 mole 1 mole electrolyte that produces electricity is what is your molar conductivity. Fine.
Yeah.
Okay. Now, so what is the how it will be represented? So this is the representation. Lambda m is the representation of this molar conductivity, and the formula of this molar conductivity will be lambda m equals to k multiplied by 1000 divided by m. This is the formula that you have to remember. And k is your conductivity, m is your molarity of the solution, like how molar solution you have dissolving. Okay, so k is the molarity,
Yeah.
k is the conductivity, and m is the molarity, and 1000 is what? 1000 is to just balance the equation. Okay, and
Okay.
that this 1000 helps to put this equation in liters. So that's why we just do this multiplication. Fine. So this is what. Now the next thing would be my equivalent conductivity. So the equivalent wala term that I have explained you in the solution wala chapter. So can you remember what is one equivalent? What is one equivalent, if you remember? Like I have explained you the equivalent and all, like n factor equivalent.
Molecule.
If you
So in
remember,
equilibrium, is the equi
huh?
equilibrium, is it related to equilibrium?
Is it related to equilibrium? Uh, I can say that, but it's not completely related because the equivalent part is based on, I can say that, like its amount. The equivalent, like 1 mole is the amount, so equivalent is also the amount. So it is one equivalent, or I can say that the equivalent term is used in the equilibrium. It is used in the equilibrium, like it is we are using this in the electrochemistry wala chapter, same as ki this term is used in that equilibrium. So I'll help you. So basically the one equivalent is basically equivalent equivalent is nothing but the number of gram equivalent is equals to, if you remember, number of gram equivalent is equals to molar normality into, have you remember this formula?
Yeah, it was in the starting of the chapter.
In the starting of the chapter, like number of gram equivalent equals to equivalent weight or something like that. If you're not remembering, I'll help you. Okay, just 1 minute. I'll show you the notes that is there. Just 1 minute. Hmm. Just 1 minute. So I'm sharing another PPT, that is this. So this is the PPT that I'm sharing here. So see, here I have explained you about the number. If when I have explained you about the normality, then I have explained that the number of gram equivalent of the solute in 1 liter of the solution is what is your normality. So what is the normality? So number of gram equivalent divided by volume of solution. Now what is number of gram equivalent? So number of gram equivalent is your given weight divided by equivalent.
Right.
Now,
Equivalent.
what is equivalent weight? So here, equivalent weight is the molecular weight divided by n factor.
In fact,
Understood? So this is the time that I have explained you about this, and basically the n factor is the thing that is basically defining this number of gram equivalent. Why? Because if you divide this with the molar mass, this will become the moles. Okay, when if you divide the moles, if you see given mass upon molecular mass is my mole. So if you divide this with your mole and multiply this with the n factor, mole is multiplying with the n factor, then you'll get your number of gram equivalents. Okay, and I can say that it is nothing but the amount of the compound, or the amount of the I can say that the molecule that is basically taking part in a chemical reaction. So this is what. So now again I'm sharing the another PPT that is there. So just 1 minute. So now is the PPT is visible to you? The next one, the where the equivalent conductivity is there.
Yeah, yes.
Okay, fine. So see, so this is what the number of gram equivalent is nothing but it is the number of moles. I can say that mole multiplied by n factor. Mole multiplying with the n factor. Moles multiplied by n factor. Mole multiplied by n factor. So it is the equivalent lambda equivalent equals to k multiplied by 1000 divided by n factor. Understood? Now,
Yeah.
so it is what? It is the equivalent conductivity. So if the molar conductivity is there, it means that kappa multiplied by 1000 divided by moles. Or if the equivalent conductivity is there, then it will be kappa multiplied by 1000 divided by normality. That's it. Okay, there is just one difference. Here the molarity term is there, and in the equivalent conductivity, the normality term is there. Now, if you see here, so the electricity is conducted by all the ions which is producing on dissolving one equivalent of an electrolyte is known as your equivalent
Yeah.
conductivity. Fine?
Yeah.
Clear?
Fine. Fine.
Okay, so let's discuss some questions based on this. So the first question of yours would be this. Now you just have to solve the question. This is the first part of your chapter, that is my conduction wala part. Then we'll move forward to the next part after solving some questions. Okay, so this is the question. Solve it. Very easy question. Okay, you just have to solve for the molar conductivity, and the concentration is given to you, temperature is given to you, and your conductivity is also given to you. That means K is given to you. Everything is given to you. Just you need to just put all these terms in the formula and just get the answer. That's it. Very simple. Okay.
Is the first one 0.0? 2485 into 1000 by 0.2.
Okay, so the first answer would be
0.285 into 1000 by 0.2.
okay. Let's see. Let's solve it and we'll discuss. So the question is कि the concentration is given to me. So the molar conductivity equals to kappa multiplied by 1000 divided by molarity. This is the formula. So kappa would be this one. So 0.248 multiplied by 1000 divided by the zero point 0.2. So this would be your 248 and 3030 gone. So this would be 0 0.2. So this one would be
Yeah.
your 1240. So the answer would be 1240. And what is the unit of it? So unit is, what is the unit of kappa? Kappa is your 1 upon kappa is your 1 upon resistivity. And what is the unit of resistivity? Can you tell me?
Uh, ohms. Ohms.
See, see. R
Oh,
equals
one
to
of
rho
them.
L upon A. Fine. And this is ohm. So
Okay.
ohm meter square. If you multiply this
By,
here and divide this
yeah,
meter here, so meter. So
meter.
ohm meter is
Meter.
my conduct is my unit of what? Is my unit of R.
Rho.
No, sorry, rho, not rho. R.
Rho.
It's R. Okay. It's
Yes.
rho. Now, if you reciprocal it, then the unit of kappa would be my per ohm per meter. Fine. Or I can say that Siemens. Okay. So now this is the kappa. So kappa unit of kappa would be my Siemens like this. And what is the unit of my molarity? The unit of my molarity is my molar m mole
Yes.
per liter.
M. Yeah.
Fine. So
M.
this can be the unit. If this is in centimeter, so it means that my unit would be in centimeter. So the answer would be 140 uh, per meter and per mole. So this is the answer. Now, see the next question. Solve the next question. This is the mole. This is the concentration that is given to you. Solution whose conductivity is this. Conductivity is also given to you. Everything is given.
Ohmic.
Huh?
260 Siemens. 260
Okay. So
Siemens.
concentration is 1. And whose conductivity is this? So conductivity kappa is your 26 multiplied by 10 to the power of minus 2. Fine. And multiply
Yeah.
by 1000 divided by what? 1 mole. So if you
One.
multiply this here, so 20 and 20 gone, 260 is your answer. Correct. Next
Yeah.
question. This is the next question.
1500 into
What?
0. 1500 into 0.146 into 10 raised to 3 minus 3.
Okay. So let's solve.
Mm.
So resistance of the conductivity of the cell containing this much. So concentration M is equals to 0.001 molar, and the resistance is R equals to 1500. What is the cell constant if the conductivity of the electrolyte is this? Okay, so this is there, and conductivity K is point one four six 0.146 10 to the power minus 3. Okay, so conductivity is there, molarity is there, and resistance is there. So let's solve. What is there? So what is the cell constant? So cell constant. What is the cell constant if the so cell G star is asked to me. So what is the formula? G star equals to R into K. This is the
R into
formula.
K.
So R is given to you, K is given to you. Just put the value, get the answer. So 1500 multiply by 0.146 into 10 to the power of minus 3. That's it. So if you see, uh, this will be 1.5 multiplied by 0 point this. So if I just use my calculator to solve it. So calculator 1.5 into 0.146. So 0.129 is what is my G star. Understood?
Understood.
Or is there any doubt?
No, understood.
Okay. So
Okay.
great. Now the next question. So the next question is take a second. This is done. This is done. So this is the next question. So one second. Just once again, it's just saving. So this is the question.
Sir, could you solve?
हाँ okay ठीक है. So let's start. So resistance is given to me, which is zero point 0.1 mole per second. Okay. This is the concentration, and this is the resistance. And if the resistance of the same cell is filled with this molar, okay. So same cell means what? G star is constant. So what you have to do is that you have to make two equations. The first equation where the M is equals to zero point 0.1 and the resistance equals to 100. Now this is M1 R1. Fine.
Yes.
M1 and this is R1. Now in the second cell, if you see in the second cell, the M2 is equals to 0.02 and the resistance is your R2 is your 250. Fine. Now calculate the conductivity and the molar conductivity. You have to find the molar conductivity and the kappa conductivity. Okay. Of the 0.2. So 0.2 is what? This cell. This cell. Uh, and conductivity of this cell would be this. So इस सेल की कंडक्टिविटी kappa is your 1.29. Now solve it. I have explained you everything. G star is same. So first of all, you have to make sure कि G star equals to RK is there. So you have to find what? You have to find K of this. So for that, G star is constant for this one and this one as well. So what you have to do, first
Okay.
of all, if you want, find this G star here from this one and then equate this with this equation and then find your lambda. Fine. Just solve it and tell me the answer.
Is K 129 by 520?
What?
Is K 129 by 520?
Okay, so sir,
And
देखो. So point one, so G star equals to RK. So for R is 100 and kappa is 1.29. So the answer would be 129. Okay, so this is for G star. Now, this thing you have to equate with this one. So K you have to find here of this and 520 is your this. So K equals to 520 divided by 129. Okay, so this is the answer for the K. I'm not going in the decimal wala part. Now for lambda K is 520. 520 multiplied by 1000 divided by 129. Second.
yeah.
Divided by 129 and multiply by the molarity, which is 0.02. So after solving, you'll get your answer. Understood?
Yeah, that's
Okay, so this is the process that you have to follow. Now, the next
okay.
question.
Is K 520 by 129 or
What?
520? Yeah. Is K 520 by 129 or
हाँ.
129 by
What you're saying, I'm not able to getting what?
or what's K? Is it
It's
520 by
520
129
divided by 129. This is K.
or is it 129 to
129 multiplied by 0.02. This one.
no, is it 129 by 520 or is it the other way around? K.
This one. Once again. Like this K. K.
Yeah.
So this is 520 divided by 129. This is the answer. See, 129 is my G star. K that you have to find. 520 is your
Yeah.
resistance. So you just apply the formula G star equals to R
Yes.
K. So G star is 129. K that you are finding it, R is 520. So K 520 divided by 129. No, okay, just oh, I have done a mistake. Just one second. Correct, correct. You are correct. So it would be 129 upon 520.
Yeah.
Yeah, yeah, you are correct. This one. So this is uh 129 divided by 520. Correct. So 129 divided by 520. Correct. So now you have to solve it by your own. Okay. Now let's move on to the next
Yeah.
part. That would be this is the next question. This one. Okay, so this is your question. Solve it. Hello,
Yeah.
Alicia. Are you done?
No, sir. Could you solve this
What
now?
are you doing?
No, I didn't. I thought you were going to take another question on this.
No, this is the question that you have to solve.
Oh, okay.
You solved it.
No, no.
Is it visible on your screen or not?
Yeah, it's visible. It's visible.
So you solve it, yeah. I'm waiting for you. That's
So,
actually I'm having one exam of mine tomorrow, so that's why I'm just doing other work as well side by side. So that's why I'm just asking. Okay,
okay.
there's an assignment, very important assignment of mine, so that's why I'm just. You have just 1 minute of this. Okay, just solve it and tell me we have to move forward to the next question. Please understand.
Yes.
Done.
No, I can't define K.
Okay, so basically concentration M equals to 0.05 mole per liter is given to me, and the diameter D, that will be 1 centimeter, length that would be 50 centimeter, and the R is given to me, that is 5.55 into 10 to the power of 3. Okay, ohm is given to me. So I calculate the resistivity and the molar conductivity. So resistivity is your rho. Resistivity is your rho, and molar conductivity is what? Molar conductivity is lambda m. These two things that you have to find. So for that, first of all, R is given to me, L is given to me, area you have to find, diameter is given. So what
Yeah,
is the formula? Pi r square. So just apply the
that's
formula, pi multiplied by 0.5, that is the radius, arc square. So this would be pi by 4. This would be pi by 4.
yeah.
So this is what? This is my area, and this is the length. So just put the values. So basically R is equals to
Yes.
R. So rho equals to A upon my L. So R is given to me, which is 5.55 into 10 to the power of 3, multiplied by area. Area would be my pi pi by 4, and L length would be my 50. So now this is the thing. And after solving, you will get your rho. And now what is lambda m? So lambda m is what? My K multiplied by 1000 divided by molarity. Understood? Now, so what is the
Yeah,
value
understood.
of K? So what is the value of K? Can you find it?
Okay,
How you'll gonna find the value of K? So just remember the formula, G star equals to R into my K.
I need to K.
And is the
Yes,
G star given to me? Yes, G star is given to me by, because see, L by A is the G star. So if you just find L
yes.
by A, you will get your answer. So L by A is what? L by A is my 50 divided by just one second. So this is in centimeter, na? So you have to convert this into meter like this. Okay, if the answer, if you, so
Okay.
see, like there's two things. If you want to put your answer in centimeter, so you do not need to convert this into your a meter and all. So there's just put the value as it is, because I have put in this diameter, or I can say that radius in point in centimeter as well. Point 0.5 is this in centimeter now, so that's why. So 50 divided by okay, G star is 50, and area is my pi by 4. So pi, and this is 4. So this is pi by 4. And resistance is, which is there, which is 5.55, and multiply by kappa. So kappa, that you have to find here. So multiply by 10 to the power of 3, multiply by K. So after solving this, you will get your K. So K equals to 50 multiplied by 4 divided by 5.55 multiplied by 10 to the power of 3 and divided by pi. Is it K? Have you understood this, or
Yeah,
there is some
yeah, I
difficulty?
understood.
So just
No,
put the
I understood.
values.
Just
So just put the values
that.
like 10 to the power of 3 pi. So you have put in the value of K multiplied by 1000. So 1000 gonna cancel out with each other, and molarity. Molarity is 0.05. So molarity is 0.05. That's it. That's it. Very
Yes,
simple. So now just solve this one, and you'll get your answer. Understood? So the calculation
understood.
part that you will do in your home.
Yeah,
Fine?
fine.
Okay. Now let's move on to the next part, that is this. Okay. So the next part would be the variation of the conductivity with the dilution. Variation of the conductivity with the dilution. So this is the variation of the conductivity with the dilution. So on dilution, the conductivity decreases because number of ions per unit volume decreases. What does this means? So we are discussing the variation of the conductivity. Conductivity is my K, and dilution is what? Dilution is that you are increasing the molarity. So the graph is between your molarity, like concentration, and your K, kappa, conductivity. So conductivity is what? Conductivity is the property of of a material, I can say that property of an electrolyte, that how it is, how this electrolyte is basically helping the ions to flow through it. Like it is the property of the electrolyte. Like I'm having one electrolyte like shahid, and I'm having water. So if I put the if I apply the potential difference across the sugar, or I can say that the honey, or I apply the potential difference in the water. So what do you think? In which of the following solution does the electricity will flow, completes a circuit? So it would be water. Why? Because there is some
Water, yes,
electrolytes that
water.
is there in the solution, which will easily
Yes.
move from one position to the other position. Okay. So it means that its conductivity is more than the honey. Understood? So this is what the conductivity is. Now the molarity, dilution. We are diluting it. Why? So on dilution, the conductivity decreases. This is the most important thing. If you are diluting, like if I am having this is the beaker. See, this is the beaker, and in that beaker I'm just diluting it. I'm diluting, I'm adding water more and more and more and more and more. Fine. If I'm adding water, if I'm increasing the molarity, then what is happening? If the molarity is increasing, or if I say that if the conductivity is increasing, conductivity is what? Conductivity is the conductance per unit volume. This is, let's say this is 1 unit volume. Okay. So the conductivity through this 1 unit volume. So the conductivity through this 1 unit volume is my what? Is my conductivity. So on dilution, like on increasing the concentration, my conductivity decreases. So the question is why?
Decrease.
Question is why? Because if you see that, like this is the specific area that is it is already defined. This is the area that is already defined. So if you see that in this area there are some particles, like here. So there are some particles which is there in this unit volume area. Now in this unit volume area particles, what is happening? If you increase the dilution, the particles which is there in a particular area is basically going to be separated out. Why? Because the volume is increasing. So if the volume is increasing, then the number of particle after increasing of the volume, this would be lesser than it was there in the previous section. So this will be lesser. Like, see, this will be lesser. This one second. So see, the number of particle will be lesser. The number of particle will be lesser in this volume. So what has happened here? The thing that has happened here is that my number of, just one second. My number of particle is decreased from this volume to this. Like, see, now the one number of particle is decreased. So if the number of ions is decreased in a particular unit of volume of area, it means that what? The conductivity decreases. If the electrolyte is more, the conductivity is more. If the electrolyte is less, then the conductivity is less. But what will happen with the molar conductivity? Now, the question is between two things. The one is my conductivity, and the other thing is my molar conductivity. So in the molar conductivity, we are not defining a particular area. We are not defining a particular area. Why? Because now we are having a complete volume. So if you see that if I increase the dilution, then my concentration increases. See,
Yes.
on dilution my concentration increases, and if my concentration increases, it means what? The electrolyte increases. So if the electrolyte increases, it will result in more conductivity, it will result in more conductance. See, this is a unit volume area. If you increase the concentration in this complete volume area, what will happen? The number of electrolyte increases in this complete volume. See, this is the complete volume. In this complete volume, the number of electrolyte increases. So if the number of electrolyte increases, it means what? It means the conductance increases. Now let's see to the next point. The next point is that if I am just asking you about a conductivity. So conductivity is for K, and K is what? K is the
Yeah.
unit volume. K is defined for unit volume.
Yes.
Like if you see that this is the complete solution. So if I taken the unit volume from this part or from this part, the unit volume will be same in this part and this part. Okay. So if the unit volume is same at this part and this part, and on increasing the concentration, the number of particles present in that volume will be decreased. Why? Because the separation between the two particles will increase. And if the separation between the two particles is increased, so it means what? It means that the number of particle decreases in a particular volume. In this particular volume, the particle will
Volume.
decrease in this small volume. This is the unit volume. So if the number of particle will decreases, it means that what? My conductivity decreases. My conductivity decreases. But what will happens with my conductance, molar conductance? It will increase. Why? Because ultimately, if the number of particle will gone from this volume to other volume, na, this volume to different point, and this different point, the one electrolyte is added in that point. So it means that overall my conductance is increasing. See, overall what is happening? My number of electrolyte is increasing, but per unit volume it is decreasing. There is two things: per
decreasing.
unit volume and in complete volume. So in per unit volume it is decreasing, but in complete volume it is increasing. So it means that my lambda m is increasing, my conductivity is decreasing in a unit volume. There is two things: lambda m and conductivity. So lambda m is
Conducting.
molar conductivity. So molar conductivity is increasing. Why? Because it is defined in one unit volume. It is defined in one volume, one molar volume, and it is defined in unit volume. So there is a difference in a unit volume and a complete solution. So if you see the
Yes.
graph, the variation of the conductivity, molar conductivity, the relation. So if you see, this is the strong electrolyte. This is the strong. So if I'm saying that key on increasing the dilution, the number of electrolyte increases. But you know that key, this if the strong electrolyte is there, then in the strong electrolyte, my complete dilution is already happened. So if my complete dilution is already happened, then how my conductivity will increase? If the 100% dilution is already happened,
Hmm.
or if I increase my dilution, if I increase the water, my complete dilution is already done. My complete dilution of the electrolyte is already done. See, my complete ionization is completely done. In what electrolyte? In strong electrolyte. But what will happen with the weak electrolyte? The number of ion is increases. Why? Because weak electrolyte is the partial dissociation. But if I talk about
Yes.
the strong electrolyte, it will be what? It will be complete dissociation. So if the
Completely.
strong electrolyte is there, that means that complete dissociation is already happened before the dilution or after the dilution. Then how this spike is observed? How this spike is observed? What is the spike here signifies? So if you increase the dilution, my molar conductivity, what is happening with my molar conductivity? My molar conductivity is basically increasing. See, this is the concentration. So if the concentration is decreasing,
Yeah.
see, if you go here, go here. So what is happening? My conductivity is increasing. Why? Because
Okay.
already the number of particle is same after the dilution, and before the dilution the number of particle is same. So how this slight increase is there? Because the separation is increases. So if the separation between two particles is increasing, that means that they will get more area to move on. They will get more area to move on without collision. Without collision they will get more area to flow. Understood. So if
Okay.
the collision is less and they get more area to flow, it means that the electricity will conduct easily. So that means there is a spike, there is a slight spike. But if you see here in a molar conductivity with a weak electrolyte, there is a very huge difference. See, this is the graph. There is a exponential graph. Why? Because here the
Yes.
number of particle is increasing, because before the dilution there is some different dilution, there is some different dissociation, percentage of dissociation. Let's say before dilution there is 20% dissociation is there, but after dilution there will be 50% dissociation. So if the 50% dissociation is there, that means that the number of particle will be increased up, and if the number of particle will increase up, then it means that my molar conductivity increases. Understood?
Understood.
So these are two graphs for the strong electrolyte, and this is for the weak electrolyte.
And we can.
Clear? If you have any, just take 2 minutes and just observe, just
Yes.
analyze everything, and then ask me the doubts that you have.
Yes.
Just 1 second, okay?
Okay.
Hmm. See, and just ask me if you have any doubt.
And could you repeat the weak electrolyte again? The last one.
Could I repeat what? Which part?
The weak electrolyte.
Okay, weak electrolyte. Okay, fine. See. I'm explaining you, okay?
Okay.
Just see, this is the blank page, okay? I'm explaining the blank page. See what is happening here. So there is two terms. There is one is my conductivity and the other one is my molar conductivity. This is conductivity. And by definition, the conductivity is for a unit volume area, unit volume, 1 unit volume. So it's a very small volume, 1 unit volume, just 1 unit volume. Fine. And this is what? This is the molar conductivity. And in the molar conductivity, the definition says me that ki, uh, all the electricity conducted by all the ions, electricity conducted by all the ions, electricity conducted by all the ions, if 1 molar solution is dissolved. If 1 molar solution is dissolved. Okay, so if my 1 molar solution is dissolved, then the total conductivity that is there in a solution by the electrolyte, by all the electrolyte, would be my molar conductivity. So this conductivity
Yes.
is defined for complete solution. This is the complete
Yeah.
solution.
Yes.
So the
Yeah.
number of particle which is there in this complete solution will responsible for the conduction of the electricity. Fine. Is it
Yeah.
now clear? Is this point
Yeah.
is clear?
Yes, it's clear.
Now, what is this? What is this? Kappa. So kappa is unit volume. So I have to take unit
On.
volume. So see, so this complete volume is made up of many sections, like many unit volumes. See, this is one, this is two, three, four, five, six, seven, etc., to infinity. Okay, so there are infinity unit volumes that is there in a solution. Infinity unit volumes like this. है ना? So I'm just taking 1 unit volume from any position. I'm just taking 1 unit volume. So this is my 1 unit volume that I have taken from this complete solution. And in that 1 unit volume, there is some particle which is there like this. 1, 2, 3, 4, 5, 6. है ना? So what is happening with this volume? So if you just dilute this into a if you dilute the solution, and if it a weak electrolyte, it is a weak electrolyte. That means that the weak electrolyte is partially partially dissolved. So on dilution, the more dissolution is happening. More dissolution. The if let's say 20% is dissolved, after dilution, it will become 50%. So if it will become 50%, if it will becomes 50%, if it will become 50%, then see, if it will become 50% means that key 100% volume is there, and that 100% volume, the 20% to 50% is increased. It means that the number of particle is increased. Number of particle
Okay.
is increased. So number of
Yes.
particle is increased where? Where this number of particle is
The
increased?
solution.
In
The
the solution.
solution.
Correct. 100% increased. So where this 100% is in the complete solution. But if you see a particular unit volume, in that unit volume, if you increase the volume, if you dilute the thing, then what will happen? The volume is increases. The
Yes.
volume increases or not. So if the volume is
Yeah.
increases, so initially the volume is this, then after the dilution, the volume becomes more. It will rise up like this. It will rise up from this position to this position. So there is increase in the volume. There is increase in volume. Fine. Volume is increasing. It means that in the unit volume area, the number of particles which is there, the number of particle which is, let's say 10 number of 10 particles are there in this. So on increasing the volume, if the volume is increased, it means that my number of particle in that volume is becomes decrease. It will decreased. Let's say now it
Decreasing.
will be 5. Why? Because the particle will be separated more. Why?
Yeah.
Because the volume is
Okay.
increased. So if the area is more, then my number of particle will be more separated. So if the number of
Yeah.
particle will be more separated, then the number of particle that is enclosed in that unit volume will decreases. So 10 to 5 is happening here. So what is happening? My kappa is decreasing, my molar conductivity is increasing. So this is what I have to try to understand. Now is it clear or is there any doubt?
No, it's clear. I understood.
Fine. So now again the same thing for the strong electrolyte, molar conductivity slightly increases with dilution. For weak electrolyte, the on dilution, the degree of dissociation increases due to which the number of ions increases. The number of ions increases. So if the number of ions increases, so the molar conductivity increases. So that it
Yes, yes.
means that molar conductivity increases, kappa decreases. Why? This is why if the examiner asks you the reason is that number of particle increases. Number of particle increases. And if the examiner asks you ki why this decreases, why the conductivity decreases, where is the conductivity? So if why the conductivity decreases, so the answer would be key number of particle decreases in a unit volume. In a unit volume, the number of particle decreases due to increase in the volume. Now, on dilution, the volume increases. The reason is there. Volume increases and the conductivity decreases because increase in the volume greater enough to compensate the decrease in K. The same thing. That's why this thing is increases. So this is all about for this class. If you have any doubt, you can ask me because we have completed the first part, which is the conduction part. If you have any doubt, you can ask me any doubt. Like we have started from here. And I'm giving you 30 seconds for each slide. And if you have any doubt in any slide, you can ask me.
What did rho stand for? Is it
Rho stands for,
is-
rho is my
yeah,
specific resistance, resistivity.
resistivity? Yeah.
Yeah, resistivity is the unit volume opposition. Conductivity is unit volume, conduction, ease in the flow.
Okay. What's the difference between resistance and resistivity?
The difference in the resistance and the resistivity is that the resistance is the opposition in the flow of the ions.
Yeah.
Like it is opposing the flow. That is basically responsible for the electricity. And what is conductance? It is opposite of the resistance. It will helps to pass through it. It will helps to pass. It is ease in the flow. It is reciprocal of each other. Like anything, if you want to state, then there is two way to state it, like in an active voice and a passive voice. So if you want to if you want to see this one like this, then conductivity is basically what is reciprocal of the resistance. So if you want to explain anybody that this material is very highly resistive, so you can say that it is a very poor conductor. If any material is very highly resistive, we can say that it is very poor conductor. So
Yeah.
or I have another thing, I have another way to say this, it is very good insulator. There is two things, like very poor conductor and very good insulator. The two things are the same. Why? Because I'm stating one object by two different ways. So this is the same thing, like resistivity and the conductance. Conductivity is the two opposite things as the conductance and the resistance. Now the next slide. Any doubt you can ask me.
No, I understood this.
Okay.
Yeah, understood. Yeah, I understood this.
Fine. Next.
Yeah, this also I understood. Yeah, this also. Okay. Yeah, I understood this. Yeah, I understood. Yes, understood. Yeah, I understood this also.
Okay. So we are done with today's